Hey, thanks for joining me. This is Walter Lai's presentation of case study 2. So the objective of this case study were to create two predictive models, one to predict an employee's salary and the other to predict an employee's attrition, whether or not they quit their job voluntarily. And I'm going to start with attrition first. So we have a data set of employees containing various information about their age, their gender, how long they worked at a company, etc., and whether or not they attritioned, and their income. So we're going to start with attrition. Which factors are most associated with whether or not an employee attritions? We can see, so these graphing functions were taken from David Joseph's TeachR package, the link of which I've included here, and the graphs we use to determine whether or not a categorical variable is related to attrition are these parallel bar graphs, and we can see that overtime employees have a larger proportion of attritioning from the job as opposed to non-overtime employees. This would be good for inclusion in a predictive model to predict attrition. Also, a good model for inclusion is job role. We can see different job roles, particularly sales representatives, have a much different chances of attritioning compared to other job roles. Which numerical variables are most influencing attrition the most? We can see that, again, these are the same graphing functions taken from David Joseph's library, and we can see that the lower income employees have higher rates of attrition. We can see that employees who score 1 on job involvement are much more likely to attrition than others. And work-life balance is also a good variable for inclusion in a predictive model predicting attrition, as we can see, because scoring a 1 on work-life balance makes an employee much more likely to be attritioning from their job. And we So I performed multiple simulations of a naive Bayes classifier using different variables to measure the accuracy, sensitivity, and specificity after each trial, and averaged these three metrics for each variable to suggest which variable to include in a predictive model predicting attrition. And we can see, so ideally when I'm looking at this graph, I'm looking for the graphs where the green dots and the blue dots are very high and they're very close to one another, so that it's not simply one predictive model predicting no for attrition all the time. And the best candidate variables for inclusion seemed to be monthly income and the particular best one was work-life balance, as we can see that the specificity and the sensitivity were closest to one another, and they were both very high. The accuracy, sensitivity, and specificity for every categorical variable was also calculated using the naive Bayes classifier and running multiple simulations, and we can see that job role and marital status are two of the two of the variables that have the highest specificities and also very high sensitivity, and would be good candidates for inclusion in a predictive model for attrition. Through trial and error, I arrived at a model that used overtime, job role, and work-life balance to predict attrition, and we can see that there's a mean sensitivity of 75%, meaning that if an employee that actually did not attrition was presented to our model would predict that the employee did not attrition 75% of all those employees. The 68% on the mean specificity represents the percentage of the chance that our model will catch a future attritioner if he or she is presented to our model. And the second predictive model that was created was used to predict income, and we can see the two highest linearly correlated to income were the square root of total working years and job level. We can see the factors that are most associated with income are the job role factor and the department factor. And through trial and error, I arrived at a multivariate regression model that used total working years, job level, job role, and years in current role to predict an employee's salary. And the effect sizes were calculated by taking the exponent, the e exponent of every coefficient of each variable. So for example, the total working years exponent is 1.0878, which means that there is an 8.78 increase in median monthly income for every additional square root because we use the log income. The other variables are shown here. And our salary predicted performance show that it explained 89% of the variation in log of the monthly income after adjusting for a number of variables used. So thank you for this presentation, and I hope you got something out of it.